Good morning. We wait for a while until all of you will come back. We'll start over the lesson at 10:25. Now, while we are waiting, if you have any questions about chemistry, you may ask me now. Now, a reminder to all of you that once we start over the lesson, could you please turn on the camera and let me know where you are here. Thank you. Any questions about chemistry? Now, a reminder to all of you, you have to submit your MCs together with explanation. Today and tomorrow, we are going to have 2 more sections to go. And I found, remember to show me your working steps. Okay, either on a piece of paper or you directly write onto your MC. Both they are possible, as long as you show me that is your working steps. Time now is 10:23. Let's wait for a while. Okay, as a practice, please turn on the camera. Let me know you're here, and yeah, thank you. And we will start over the lesson right away. Now, to start with, please take a look on page 41, question 19. We try to do this as a start. And at the same time, could you please open the camera and let me know you're here. And throughout the lesson, I would like to ask you guys to turn on the camera for long and to allow better. Thank you. Let me see. 1, 2, 3. 1, 2, 3. Oh. Yong Seng Hiên. Anyone who saw Yong Seng Hiên? Yong Seng Hiên. No. Oh, Yong Seng Hiên just coming in. Now, all of you here, we'll start over the lesson now. So, welcome all of you. And today, we are glad to have our student teacher, Mr. Mac, to come to us. So, shall we welcome him? And he will take over the lesson next Monday. Starting from next Monday. So for Chem 1 students, you will have the lesson every day 1, day 3, and day 5. So he will be with you before from next week until before Easter holiday. Okay, so this is what the information I would like to share with you. And it will teach in the following chapters. So because of the pandemic situation, it will be what a pity that we cannot see each other well in face to face. But anyway, it's always like that. Okay, why we so laugh so embarrassingly, so strange. Could you please open the camera? Let me know you're here as well. Thank you. Now, before I start the lesson, and also Him, could you please try your best, find your camera and turn it open. Before I start, I received one question from your student, your classmates, mocel. You asked something about mocel, which is how many atoms and ions are there in Na2CO3? Okay, now if the student don't mind, I just post the question directly onto the chat box again. CO3. He has this substance, Na2CO3. How many atoms and ions are there in Na2CO3? So he wants to ask is the answer is 2 Na plus iron, 1 carbonate ion, or 2 sodium atom, 1 carbon atoms, and 3 oxygen atoms. So what makes this? If you want to, anyone who can answer this question. Looking here. How many atoms and ions are there in Na2CO3? Sodium carbonate. Is it counted as ions or atoms?
Ions.
Ions. Okay, how you split that?
CO3 減
CO3 minus and sodium ion Na. What charge is it? Plus. Okay, so with the two mole ratio 2:1. So I try to change the question a little bit. He should be asking for 1 formula unit, okay, of sodium carbonate. It contains sodium ion and carbonate ion in 2:1 ratio, okay, but not counting the atoms. So there's the Na here doesn't refer to atoms, it refers to ions. Okay, so the sodium ion is a cation, positive charge, while the anion is carbonate ion, CO3 minus. Okay, I hope it will be make it clear to clear the student doubts about this. Okay, any more questions about that? About mole-cal? Now, all of you notes, you would see question 19, page 41. We have got this question, very authentic, very typical example to talk about the preparation of ammonia gas. Okay, so we have got this setup like this. So the question comes. Number 1, write the chemical equation for the reaction between ammonium sulfate and calcium hydroxide. Let's have a warm up. Anyone who know the answer for this equation?林曉芳. The equations. Let's have a try on this. Ammonium sulfate and calcium hydroxide, the reaction to form what? Mr. Lam? Thinking. So you would have a clue on top to produce ammonia, okay? So of course, one of the chemical is ammonia. What else? We have got 3.
Calcium sulfate and water.
What sulfate? Sorry, calcium sulfate. Yep, thank you. Calcium sulfate, ammonia, and water. How to balance the equation? Now, I would like to show you this. It is sulfate, calcium sulfate. Okay, while this is ammonium ion, hydroxide ion to form ammonia gas and water. Okay, so it seems like if you study something more, about our equation, we usually use that tricks. Okay, balance the equation now. Please balance the equation. Chen Zhaming.
Yes.
Yes. Show me your the mole ratio of
2 ammonia.
Or 2 ammonia.
2 H2O.
2 water. Okay, and all others they are just 1. Right? Agree? So this is
yes.
Yeah. How about the stick symbol? Mixture of 2 solid. Right? So is it solid? Solid. How about this? It's gas. It's liquid. How about calcium sulfate? It is in form of solid. okay, because it is water insoluble. It is a water insoluble salt. So you mark it as solid. Okay, usually if you are going to have AQ, right, react together, usually the salt form is also in AQ. But for this case, calcium sulfate is not water soluble, so we mark it as solid. Okay, is that clear? Now, the question comes, you will see the setup, it will be quite complicated because the setup is now split into 3 parts. Okay, can you see that? The setup has to be split into 3 parts. The first part, in general, okay, we call that as a reaction chamber, or we call that a reactor, okay? Fine. So this is a place where the reaction that will take place. And how about the second part? What is the purpose? What is the purpose of this? Second part, the middle one. Do you know what is that? Drying agent. So it is a place where drying of gas will happen, okay? So the gas here will pass through the drying agent, okay? They will pass through the drying agent. How about the third part? The third part, it is what we call it as a collection of gas. Okay, so in short, whenever you see that setup, please focus on these 3 parts. Okay, please focus on these 3 parts. So my lesson today will mainly cover on this. How would you tackle this type of question, this type of problem? So to start with, we start from number 1, reaction chamber. Now you will see this setup we put the boiling tube horizontally to place the solid in such a manner, right? Have you ever seen some other way of heating the chemicals? You've seen that, right? For example, this. And also this. Have you ever seen that? We've got 3 ways of heating the chemicals, right? Choice A, choice B, and choice C. Okay. Under what situation will you use A or B or C? Do you know? Anyone who know? Do you know this? Have you ever seen 3 different types of setup?
I don't know.
You don't know? Have you seen that? For example, this, right? Right, this is the place, right? What you see. And also you will have this setup. Now you turn over the book. Now turn to previous pages. Now, for example, you talk about the fountain experiment. Do you still remember the page on fountain experiment? Now, even though it is not in it's not put it into the boiling tube, okay? But I will see the mouth of the container. It is slanted downward. So which means that they tilt at an angle, okay? With the mouth pointing downward. Do you understand? So we have got that 3 cases. Now the question comes, under what situation we'll use different types of that? Anyone who know? Now it's a brainstorming section. Anyone who know?
Is that depending on the gas, the density of the gas produced?
Or somebody may think that it is depending on the density of the gas. Could you please elaborate more on the density of the gas?
If the gas is less dense than air, it should be used. The slanting downwards method should be used.
This one. What I mean is this one. Yeah, you mean this? Yeah.
Yes.
Which means that the gas collected will have a high density or low density than air. Lower density than water. So higher ammonia. Do you agree? All of you agree? James, do you agree?
即係佢問咁樣，即係如果咁樣擺係咪即係啱係嘛
？My question is we have got three types of heating the chemicals, right? One horizontally, two slanted downwards, three is slanted upward. So what Sewagi has been suggested that we will use the heating of solid also using this setup, right? Because what you have just shown is very similar to this, right? So the one with a round bottom flask that was slanted downward. So it seems like B. And he think that the reason behind is that the ammonia gas has a higher density than air. So I heat it like this way. Do you agree?
Higher density.但係佢本身嗰個即係 gas sample 入面係咪真係得 ammonia 先？係咪冇 air 嘅先
？You mean which part? This part? This one. So what do you think? What do you think about this shaded part? Originally, before you heat anything, what is that inside? Nothing.
咁應該係有 air 嘅佢入面。
Yes, that is air.
應該係關事嘅，我諗。
Not related. You mean not related? So the question is, what's the idea of that three setup? Which under what situation will you use A? Under what situation will you use B? Under what situation will you use C?
我頭先咪話應該係關個 density 事咯。咁如果佢嗰個 gas 嗰個 density 係低過空氣嘅話，咪用 C 咯；高過空氣用 B 咯；差唔多嘅就 A 咯。
Oh, I see. So, you mean that if you take a look at the gas having a higher density than air, you will use this. Lower density. Okay, you use this, right? You mean this? And how about this? The density similar to air, is it?
Hello.
Or similar. Density similar to air. It is like this, okay? Anyone who agree with this proposal? Anyone who agree or who doesn't agree? Agree. If you agree, just put a tick. If not, a cross. Let me know now. Agree or not agree? the proposal listed on those in red. Now, many of you will think that it is the red one is correct version, huh? But I see two of you, Zhang Deliang and Lei Jingho, put across. So I need to take a question on Zhang Deliang. Why?
I think it's related to the reactant, and they react together if they form a product of water. So if it form water, I should use A instead of B and C, because the water will react to the reactant you are heating again. So if I use C, the water will react again, and it makes the whole reaction is incomplete. And B, the water may pass through the from the delivery tube. If you so like this experiment, so if I use B instead of A, the water may pass through to the drying agent. So I don't think it's work. Or C doesn't work also. So it quite depends on is it form water.
Okay, it depends on whether or not the whole reaction will produce water, you mean?
Yeah.
But anyway, if you use that, let's put it this way. If I put this as an example, okay, you can we use B or C? No, it's because of the water. For B, the water will flow into the drying agent, while the C, the water will drop back to the reactant, while the reaction is not complete. You mean this?
Yes.
Okay. Thank you. How about Lei Jingho?
I think it's dependence on the producer's gas is contain water vapor or not, which is the density of water vapor will cross back to the reactants, then the reactants will not be reactant more completely.
You mean water? They will very similar argument, right? The water will drop back to the container while the reaction will not react, right? It will not react, no longer react. Do you mean that?
Yes, similar.
Very similar. Okay. Now we have got two arguments. First of all, if you study science or chemistry, we love to argue. We are going to clarify the 2 points. Number one, ammonia gas, is the ammonia gas having a higher density or lower density than air? Okay, question one. You think it's higher? What Zhang Haojing has been suggested is higher, right? If it's higher than water, how about the collection of gas? Take a look on this. Why would we collect the ammonia of such position? But not this. Can you get my point? So we have got that two set up. You may have seen that statue. Is ammonia gas having a higher density than air or lower density than air? So what will happen if the ammonia has a higher density than air? If I put this here, air is just outside, ammonia is here, while the density is said to be higher, what will happen to the ammonia? Do you understand? What will happen? What will happen to the ammonia?
It will sink and escape.
Okay, the ammonia gas will sink and escape. How about this? If I put ammonia here, like this,
it will be contained in the funnel.
But the setup I show it in is on here. It's like this. So
therefore, the ammonia gas is less dense than air.
Yes, ammonia is less dense than air. Okay, so it will have the high density. This statement is not correct. It is lower density. All of you, please mark it down. Then air. Only by doing so, the ammonia will stay here. Okay, ammonia will stay here. Once the ammonia will stay here, what will happen? It will push those air downward instead. They will dispel the air away. Okay, so we would call this setup a upward delivery of gas. All of you, please mark it down. Upward delivery. Of ammonia gas. Upward delivery, so which means that you are going to you are going to let ammonia rises upward. Okay, to direct them into the upper position. In order to dispel the air that will push downward. So we will call this one a displacement of air in a downward direction. All of you, please mark it down. We call that a downward displacement of air. So you take a look on this setup. This setup, you are going to tackle. You cannot going to tackle ammonia. We would tackle what? We will tackle the gas which is denser. All of you, please mark it down. The gas which is denser than air. Any example? Any example of such gas? Any example?
Carbon dioxide.
Yep, good. Carbon dioxide. Carbon dioxide. Okay, so we will call this, what will we call this setup? We call that downward delivery of gas. Or you may find that the air is displaced in an upward direction. So we will call it upward displacement of air. Can you get the point? So to clear the doubts of the people who are just suggesting here. So it is nothing to tell about the density, okay? Because what you just suggested is contradictory, okay? It is not because of this. So of course the air is inside, that is the fact, but we are not intended to do this. And indeed, no matter what gases it is, okay, inside, okay, no matter what gases it is inside, the air will still go out. Do you know why? The air will still leave, first of all, no matter the product gas is a high density and low density. Because whenever the reaction reacts, here comes the gas that will push, okay? The gas will push away those air out. Okay, you get my point? Because inside, if I end up heating, the air pressure inside will increase. So anyway, something will come out. Okay, no matter it's A, B, or C, something will come out. Some gas will come out. Okay, of course, mainly for the first few cm cube is air. Later on, they will get mixed with some other gases. What I mean is the product gas. Is that clear? Now take a look on this. It seems that Mr. Chin have cleared the doubts of number 3, right? Collection of gas, we have got that too. Do you have the third method? Yes, we have got the third method. I would like to show you here. We try to solve this one first of all. And we have got the third case. Have you ever seen the collection of gas like this? With this gas jar full filled with water, and you are going to collect the gas like this. Have you ever seen that setup before? Right? Between the metal with the water, right? Do you still remember that setup, right? Does it, can we apply this into collection of ammonia as well? Can we? Can we? Oh, yeah. Can we?
No.
Why not?
Because the ammonia can dissolve in water.
Yes. What will happen if I find that ammonia gas is highly water soluble? What will happen? If I put ammonia gas into it, highly soluble in water, what will happen?
The ammonia will dissolve in the water.
Yes, the ammonia dissolves in water. What happened to the tube here? Can we collect the gas? No, but instead something will go inside. So what will we go inside?
The water will be sucked up.
Yes, water will suck up. So in chemistry, we would use a very technical term. We call that not suck up. We call that sucking back. All of you, please mark it down. Sucking back of water. Okay, if you use ammonia, they will sucking back of water. So you never use this setup. Okay, ammonia, no. Please do not use this setup. Which means that the gas should be water insoluble. If you use the gas, it is okay. So what is that setup called? We call that displacement of water, or the collection of gas underwater. Do you understand? Okay. Now, of course, you may find some other method, just like collection of gas using syringe. Have you ever heard, seen this one? Syringe, 氣筒 gas syringe. I collect the gas using gas syringe. Now this is another one. So altogether we have 4 setups. But for collection of ammonia gas, this one is the most suitable one, okay? Because you are going to collect the ammonia gas. While the ammonia gas is highly water soluble, never use collection of water. And also ammonia gas has a lower density than air. So they will float, and which will help displace the air downward. So you use upward delivery of ammonia to be the case. Is that clear? So I need to draw that, spell the word very clearly, such that all of you can see it. Delivery, D-E-L-I-V-E-R-Y, upward delivery of ammonia. Okay, any questions? You clear the doubts on point 3? Do you understand? Now we have got 3 methods. 4 methods actually, where while you choose upward delivery gas is the most suitable one. How about number 1? You go back to this. You go back to this. Indeed, for A and B, you will usually see it. Now, I would like you guys to take a look on the question. Now, for example, this. Now, you may see the setup slanting upward, with the mouse slanting upward. It's a tilt position like this. And similarly, you always see this, right? So under what situation will you see is something related to the state of the chemical? Okay, state of the chemical. If the state of chemicals, usually you may see it as liquid plus solid. Of course, you must use C, right? You never use A or B. Agree? Why can't we use B and A? If it is in liquid, so they will throw out, they will throw away, they will leave the container. Can you get my point? Of course, if somebody may argue, Mr. G, I have seen that setup before, slanted upward. But it is, for example, you heat calcium carbonate solid. I have seen that before. It's also okay, right? It's also okay to do this. So what is the difference? How come I would use, for this setup, two solid, ammonium sulfate and calcium hydroxide heated, I use this setup. And also, I can also use this setup. Can you see, can you get my point? Now you have got this setup and this setup, finally, both they are okay. Ammonium sulfate, solid plus calcium hydroxide. I can also use this, but you use calcium hydroxide and ammonium sulfate to put it here, it is not so okay. Now, but the question is, but they are both solid, right? So Mr. Chin, solids only. Now, it is not just a requirement, right, for you to choose C. Okay. Now, even though for A and B, I put it as a solid, it's also okay. So the difference lies on the term water vapor. Yes, that's right. Now, now this one is no problem because there is no water. Okay, but there is no water. So even though it's just solid, I put it. I use C. But for A and B, right, you usually deal with some water vapor that may come out. Why? Because water will come out, and what will happen? It is something about safety. The water vapor that will come out, they will condense. Yes, they will condense into the cold surface. What will happen? So they will drop it down. They will drop it down on here and stay in here. Or you will have got the cold surface. The steam, they will touch the cold surface. They will drop it down. They will stay here. Okay. I know it is a little bit problematic while you do to throw into the drying agent. But if the drying agent is solid, no problem. Okay. Because the drying agent is intended to absorb water, isn't it? Right? Dry agent is used to absorb water, so no problem. Let them absorb. Now, but what is the problem? You talk about the condensation of water like this, or even this. Water, they will drop it here and put it go back here. Okay, it's because of see something about safety. This cold water will meet some hot surface on a glass. What will happen? It will crack. Okay, a sudden cooling of the tube. That will happen. It will crack the tube. Do you understand? So yes, that's right. Somebody will know that it is something related to the product form. If the product is water, okay. If I heat it as a solid, if the product is water form, you never do it as C because there may have a chance of a condensation of steam back to the reaction mixture, which will crack the tube. It is something about safety. Do you understand? But not completion of reaction. The reactions will still go. Somebody may have doubts, right? Mr. G and I have water. I draw it back to the solid, and both of them are solid. Will they produce less ammonia? The answer is no. Indeed, for this reaction, it is not just a mixing of two solid. We can also have a mixing of two AQ. Okay, you take a look on that. Can you see that? Even though I make it as aqueous solution, we can also produce ammonia. So, what is the meaning behind is that, first of all, if you want to think of the preparation of gas, okay, you want to make a look at preparation of gas of the different chemicals. It depends on the combination. If you want to have both of them are solid, now, in generally speaking, A, B, or C, they are possible, right? If it's solid. Of course, if you use is a liquid, you can only use C. Can you get my point? If you use solid A, B, or C, in general, they are okay. If you use liquid, involving one of them, it should be liquid, only C, because the reaction mixture will flow away. But you need to think of one more consideration of the product. It is water. So water will form steam, steam will condense in the cold surface, the water will then drop back to the hot surface, so we will cross cracking. So this is something about safety. Do you understand? So in this case, let me put it this way. In this case, for ammonium sulfate and calcium hydroxide, because there was some water that is being formed. Okay, so you can only choose A or B, but not C. Is that clear? That's why if you find the previous page of this setup of having ammonia, take a look. It is placed like this way. It's landed downward as is okay. Dry ammonia gas has a low density than air, so you use upward delivery. I hope for this question, it can help you clear the doubts of both. Do you understand? Do you understand? Any doubts? Anything is unclear to you? Now you go back to the question again. It seems that Mr. Chin has covered some of the answer already. So take a look on the answer. Name the I skip B first. Name the apparatus labeled X. X is its gas jar. Okay, how about D? Why is ammonia collector upward delivery shown but not over water? Same question, right? Why you will need to collect ammonia as upward delivery?
Because ammonia has a lower density than air.
Yes, very good. So lower density than air. So you are going to displace the air downward. Okay, so you should displace the air downward to collect the gas jar full of ammonia gas. So you use upward delivery. Why not water? Now remember, you are going to answer why not water. So you are going to answer this one as well. Why not water? In order to make this one complete, a complete explanation. Nahin. Why not collect ammonia over water? Yeah.
Ammonia dissolves in water.
Yes, dissolve in water. But remember, you need to tell the term highly
water soluble.
Yes, highly water soluble. So what will happen if I put it under water? That will cause sucking back of water will occur if I do so. While you use ammonia as a lower density and air, it is used to what? Help displace the air downward to collect the gas. The gas jar, it will be full of ammonia. Do you understand? So this is our explanation. Questions? Any questions so far? Now, the last question about Yi give a test for ammonia gas. Shall we invite Sito Wang Yin? Test for ammonia gas. How?
Test for ammonia. Adding solution.
A solution. What solution will we add?
Sodium hydroxide.
So what will happen?
Ammonia gas will be produced.
So you take a look on this setup. How would you make the test for the gas ammonia more efficient? You use solution, is it? Oh, some of us, some of you cough. Have you done the test? It's not Chem test.
I don't know.
Are you okay? Are you okay? You just cough?
Not me.
It's not me. I just listened someone cough.
I didn't cough.
You better, for that student, you better take test or stay home. It's too scary. Now, yes, that's right. So, now, indeed, we would not use solution. You use a paper. Now, paper placed here, a test paper, which will help determine whether or not the gas jar is filled of ammonia. Okay, it's the easiest way. I put a paper here. What is the paper? What do you think? Litmus paper, good. There are two types of litmus paper. What type of litmus paper are you talking about?
Red litmus paper.
Yep. Remember to make it wet, okay? Place moist red litmus paper near the mouth of gas jar. Okay, you get my point. I put a piece of paper here. Okay, so what will happen to that piece of paper? The paper turns color, right? Turns its color from red to blue. So this is the test. Why we use this litmus paper? Because the ammonia gas is the only alkaline gas. Okay, so you can simply use this test paper for help. Clear enough, right? Have you finished all questions? Have we finished? No. One more question still remain unanswered. Suggest a suitable drying agent for drying ammonia gas. So what is the drying agent? Now, before you go to the previous page, anyone who know any drying agent, you may just turn on the mic and tell. For those who know it, any drying agent that you know. No? No idea?
Rice.
Rice. Under what situation will you see rice being a drying agent?
In salt.
Oh yeah, in salt in 茶餐廳. right? It's a bottle of salt with, because indeed the rice itself has been treated. It has been fried for some time. Okay, put it into the salt. It will help prevent, do you know what's the purpose? It will help prevent the salt from clumping. All of you, please mark it down. Clumping, give five. So fried rice, but not the one you eat, that fried rice. Indeed, the rice is uncooked. Uncooked rice, I use uncooked rice and you fry it. Okay, you get my point? And then you put it inside the salt, prevent the clumping of the salt. And yes, what else? Have you ever see some food packages, packaged food? For example, mooncake. We've got a mooncake here. Underneath, there is a drying agent. Okay, there is a drying agent. While the drying agent, of course, is a very small packet, and you are just told not to eat them, not to open them, right? So also it contains a drying agent. Okay, it's a drying agent. But I would like to tell you what is that? Anyone who knows what is the drying agent inside? In a commercial market, what is the drying agent? Wang Qinghua, you know? Now, white solid, white solid. Good, white solid. Are those drying agent white solid? Oh yes, white solid. Have you ever seen the powder, white powder? Have you seen that it is in form of a colorless granules? Small pieces, right? Ball, small balls, granules. GRANULES, antibiotic granules, that granules. Have you ever seen that it is in black, in terms of black powder? Have you ever seen that? Yeah. What are they? What are they? First of all, the white solid powder, which is mainly anhydrous calcium chloride. The colorless granules is mainly silica gel, 防潮珠. Okay, and how about the third one? It's black powder. It's mainly iron powder. Of course, it get mixed with salt. It get mixed with activated carbon, etc. So each one of them, they will undergo different chemical principles. Okay, you may go to the web and search for the principle. Now, I would like to show you how about in our lab. In our lab, we will use quite different number or quite different drying agents. Something liquid, something solid. Now, if you talk about liquid drying agents, we will use corn salt. Can you see that? Corn salt, concentrated sulfuric acid. And this concentrated sulfuric acid is very strange. If I unbottle it, I put it in a beaker, leave it for some time, the water level will rise. We will call this type of substance a hygroscopic. Hygroscopic means they absorb water vapor from air. Underline the term hygroscopic. And you may also see silica gel as a drying agent. Okay, but that drying agent, the silica gel is not colorless. Can you see that? What is the color? It's not, right? It is color, right? So what is the color? You may find it on the next page. Here is a silica gel. It is also silica gel, but why is it blue? Do you know? I add some chemical to it. Now it's quite difficult to guess, right? But once I tell you that if the silica gel is wet, it turns its color from blue to pink. Can you guess what chemicals have been added?
Cobalt.
Yep, cobalt 1. A cobalt compound. Cobalt
2 chloride.
Yes, cobalt 2 chloride. Yes, that's right. This is how the working principle of silica gel. So that silica gel can be reused. Put it into oven, and you can dry it, and you can use it again. Okay, you can put it back into oven and dry it and use it again. So we come to this. Okay, so we have got silica gel. What is the use of silica gel? Besides putting inside here, you may either put it here or here. It is also okay. Okay, it's solid. And let all gas that will pass through. Can you see that? The gas can pass through. The gas can pass through. It's also okay. You put it into desiccator, 乾燥器, the container, which store the chemical which is said to be absorbed water vapor. It's also okay. Now, what else? Anhydrous calcium chloride is also one of the case. Have you ever seen the drying agent? You buy it at home, right? For you put it into the wardrobe, okay, the cabinet of storing the clothes. Okay, you may use some drying agent. So it seems like cups of Banja, right? So you have got this. Some of them they sell cheaply. Some of them they sell very expensive. One of them is very, very cheap. If you see the solid being white solid being left for some time, and you would turn the whole thing watery, mainly it is anhydrous calcium chloride. Now, of course, there are some others. Now, if it's gel-like, it's not anhydrous calcium chloride. It is the chemicals exactly the same as baby diaper, okay? So, 紙尿片啦. So, the chemical inside is different. Now, anhydrous calcium chloride is just white powder, not gel-like. So, we describe this chemical reabsorb water vapor and eventually cause a very concentrated solution at dilute presence material. Okay, so anhydrous calcium chloride can be used, consol can be used, silica gel can be used, and also calcium oxide can be used. Okay, calcium oxide. Now, indeed, calcium oxide, remember, it's not just absorbing water, but also some acidic gas. Something like sulfur dioxide and carbon dioxide. So for calcium oxide, it can only absorb non-acidic gas. You can only dry non-acidic gas. While similarly, if you want to talk about consol and anhydrous calcium chloride, it cannot use to dry ammonia gas because both will react with it. Okay. Now I just mentioned those. Any questions? Now you go back to the question. Now you go back to the question about the drying agent. These two setup is not okay. These two setup is not okay. Why is it not okay? And how would you modify it? See what I get. What's the problem? Setup 1 and setup 2. What is the problem? But you may just either one to tell.
Setup 1, the problem is the HCl gas will dissolve in the water, the water contain and turn to hydrochloric acid. So
you can
lose no gas will be collected.
Now, do you know consol? Consol, how how much water is found inside concept. Now you go back to this. Good questions, good concept. Huh? So we try for that because for console, it contains 98% sulfuric acid by mass. So only 2% is water, so no problem. Okay, there's no problem. So it's not that, it's because of what? Take a look on the delivery tube. What happens to the delivery tube? Now, this is the way to do this. This is the correct version, right? This one is incorrect. What is the difference? What is the difference? Can you see the length of the delivery tube? It's quite different, right? How different is this? Check against page 32 and page 31. What is the difference between the length of the delivery tube?
The left one is shorter.
Yeah, this one should be longer. This one should be shorter, just above. You are going to place above the delivery tube. Should be placed above the delivery tube. Okay, otherwise, what will happen? The console will flow out. Okay, console will flow out. Okay, so will cause you harm. How about this? If I push this one at the position, the gas cannot be dried. So you are going to put the delivery tube inside the drying agent. Immerse the tube into the drying agent. So you let the gas to bubble it. The bubble the gas, we'll call the term bubble the gas. Can you get my point? So the left-hand side should be longer, immersed into the console. The right-hand side should be higher, just above the delivery tube. Okay? Is that clear? How about setup 2? What's wrong with it, Chen Yu? Chen Yu, are you here? Chen Yu.
Yes, I'm here.
Yeah, setup 2. What's happened to that? What's wrong with it?
The calcium oxide. I think will not react with the gaseous hydrogen chloride.
To react, okay? Calcium oxide will react with HCl because HCl is acidic. Okay, so it will react. It's a base. So they will react to form calcium chloride and water neutralization, right? So how will you tackle? I don't use calcium oxide. I choose another drying agent. Yang Zhongyi, any example? You don't use calcium oxide. I use what? Which one is suitable?
Silica gel.
Silica gel is better, right? Silica gel. Or you use anhydrous calcium chloride. Is that clear? Okay, now I go back to the main question. Mr. Chin, you still haven't told the answer. It's time you tell me the answer. This one. What is the drying agent to be used to dry ammonia gas? What do you think, Matthew? How about this? Calcium chloride. Possible? Calcium chloride. Now you take a look on the previous page. Anhydrous calcium chloride there are some limitation, right? Calcium chloride cannot be used to dry ammonia gas because they would react. Okay, so you cannot use anhydrous calcium chloride. You cannot. So what is the answer? We can't use corn salt. We can't use corn calcium chloride. We can use what? Sorry, I can't hear.
Calcium oxide.
Calcium oxide. Okay. Now calcium oxide is basic. Ammonia gas is also alkaline. No problem. Okay, because they will not react. They will not neutralize. So calcium oxide can be a choice. Yeah. Calcium oxide. Okay. Is that clear? So today we come to this topic, right? We come to this topic. You talk about the different combinations of the gas, and we have talked about the drying of the gas, how we produce the gas, and also the collection of gas by using this setup. And it's our main focus. Remember, whenever you see this this setup, remember to split that into three. First one, reaction chamber. Okay, it tells you where the chemical reaction happened. So we will talk about the chemical reaction that will happen. I need you guys to show very clearly the chemical. Whether or not the condition requires heating, you need to tell me. Remember, you are going to show me chemicals plus conditions. You need to tell. Second, it's about the drying of gas. You are going to dry the gas with consideration of two factors. One is whether or not it can absorb water vapor, but also one more important point, not react with the gas. Okay, you are going to think of these two factors. Only by doing so, you can choose a good drying agent. How about number three? Collection of gas. What should be considered? What should be considered? You are going to check two things. One is the density of gas, right? When you compare with air. How about the second criteria? The water solubility of gas, okay? If it is water soluble, you never use collection under water. Is that clear? Okay, so fair enough. So you please do the MCs, okay? Please do MCs, and next week, next Tuesday, shall we meet? We will try to talk about the MC together with some exercise. Any other supplementary section for the other subjects? Is that? Any clash with your own activities? If there is, let me know. Now, if not, can we start over the tutorial section starting from next week? We try to have a recap of that. Just like last time, remember to tell me your level of understanding and difficult parts for that. Now in the chat box, try to type this. Mm-hmm. Drying agent. Mm-hmm. 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 Now for drying, I see that most of you have got a 4 to 6, and you doubts about the drying agent, right? Mainly. Drying agent. Drying agent, of course, the drying agent should be able to dry the gas, right? Should absorb water. But at the same time, you never choose the gas, the drying agent in which it will react with the gas. So what is meant by react? Usually it is neutralization. Now, so you go back to the nature of the gas. If it is acidic, never use alkaline drying agent to dry. If the gas is alkaline, never use acidic drying agent to dry the gas. Is that clear? Okay. So you have to digest it more specific. You better do more exercise first of all, okay? So as I said before, please go home and please do the MCs, okay? And check next week. Okay, so during lesson, it is Mr. Mac to teach, and Tuesday afternoon, this will be me to cover the essentials. We have a recap because we haven't done the revision on this chapter. Okay, we'll have such arrangement. So I would like to tell you the arrangement, the lesson arrangement to be delivered by Mr. Mac through the Google Classroom message. Okay. Now, if there's no problem, see you guys. Let's have a break. Goodbye. Bye-bye.
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 Bye.